Oh, hello everyone. So in this video, I will discuss how I developed a classifier in a Colab notebook to maximize the F1 score of a separate validation set while ensuring the classifier is well fitted. So I will address two key questions. What did I do to improve the performance of my classifier, and how did I access and improve its fit. So the first one is improving classifier performance. To enhance the classifier's performance, I focused on several critical strategies. As for the data pre-processing, so handling missing values, I use the median and mode imputation techniques to fill in missing values. As for the encoding categorical variables, applied one-hot encoding and ordinal encoding to convert categorical features into numerical formats. As for scaling and normalization, use standard scalar to standardize features, which is particularly useful for models like SVM. As for feature engineering, uh, feature creation and selection generated new features and removed irrelevant ones like using recursive feature. Uh, as for the elimination and correlation analysis, uh, dimensionality reduction applied principal components analysis to reduce feature space while retaining key information. As for the model selection and hyperparameter tuning, model comparison tested a range of classifiers, including logistic regression, random forest, and gradient boosting to find the best fit for the dataset. As for the hyperparameter tuning, utilized grid search and random search to identify the optimal model parameters. As for the cross-validation, implemented for cross-validation to validate the model stability across different data splits. As for the addressing class imbalance, resampling techniques used smooth for oversampling the minority class. As for the class weights, adjusted class weights to avoid bias towards the majority class. So the second one is assessing and improving model fits. So to improve the classifier was well fitted and avoid overfitting to or underfitting, I implemented several techniques. So as for the model evaluation techniques, learning and validation curves, this helps visualize how the model's performance evolved with the training data and hyperparameter adjustments. As for the residual analysis, check the residuals to identify potential bias in predictions. As for the regularization and training, the regularization applied R1 and L2 regularization to control the complexity of the model. So as for the training, for tree-based models, I set constraints like max steps and minor sample split to avoid overly complex trees. As for the generalization techniques, so as for the early stopping, monitored validation performance during training and stopped early to avoid overfitting. Ensemble learning used ensemble techniques like bagging and boosting to improve robustness and stability. As for third one, performance evaluation and on the test set for the F1 score maximization, focus on balancing precision and recall to optimize the F1 score, particularly in imbalanced data sets. So as for the confusion matrix analysis, evaluated model performance in terms of true positive, false positives, true negatives, and false negatives. So as for the ROC and AUC metrics, used these metrics to assess the classifier's ability to distinguish between classes at different thresholds. So, in conclusion, through effective pre-processing, model selection, hyperparameter tuning, and fit assessment techniques. I was able to develop a classifier that not only maximize the FN score but also generates value to unseen data. So thank you for your watching. I'm excited to hear from the questions and feedback.